Leonardo of Pisa, better known by the name Leonardo Fibonacci, lived roughly from 1170 to 1240 and is considered to be the first important European mathematician. On journeys to Africa, Byzantium, and Syria, he came into contact with Arabic mathematics, which in the Christian Occident was largely unknown. In his work Liber Abaci, the Book of the Abacus, which was published in 1202, he combined this knowledge with his own reflections. The book long remained unexcelled in the history of Occidental mathematics and contributed to, among other things, Europe adopting the Arabic system of numbers. Liber Abaci contains a thought experiment which Fibonacci himself probably regarded as pure curiosity and did not pursue further, but which later was to become famous as the Fibonacci sequence. Fibonacci asked himself how many pairs of rabbits originated from a single pair in 1 year. To do this, he assumed that none of the rabbits would die in the course of that year, and that each pair of rabbits would produce exactly one more pair of both sexes per month, which in turn would be fertile from the second month after birth. In his book Liber Abaci, he writes, "Because the above-mentioned pair gives birth in the first month, you can double it, so there are 2 pairs after 1 month. So at the end of the first month, and it is here that Fibonacci begins counting, there exist 2 pairs of rabbits. At the end of the second month, the original pair has given birth to another pair, and the other pair became fertile. Now there are 3 pairs. Of these 3 pairs, 2 in the third month are now fertile, and 1 is not yet fertile. Thus, at the end of the next month, 2 more pairs of rabbits are added. So now there exist altogether 5 pairs. Of these 5 pairs, 3 in turn become pregnant, so that in the 4th month there are 8 pairs. To find out how many pairs of rabbits there are, Fibonacci observed, all you have to do is in each case to add up the sum of the pairs of rabbits of the 2 previous months. To begin with, there is 1 pair of rabbits. After 1 month, there are 2 pairs. After 2 months, there is 1 plus 2, or 3 pairs. After 3 months, 2 plus 3, or 5. After 4 months, 3 plus 5, or 8, and so on. Until, after 11 months, 233 pairs of rabbits have resulted from the first pair. And Fibonacci writes, when finally the 144 pairs are added to those born in the last month, in the end there are 377 pairs. And the above-mentioned pair have finally produced that many pairs at the end of 1 year. Although Fibonacci's thought experiment is based, of course, on unrealistic assumptions, it does describe the essential features of growth processes. While for Fibonacci his problem was thus solved, it was later discovered that the Fibonacci sequence also occurs in nature and in art, be it in the position of leaves and plants, in the spiral form of mollusks, in the structure of clouds in an area of low pressure, and in paintings, the architecture of buildings, and in music. It is also possible to approach the Fibonacci numbers geometrically. Let us assume a square whose sides measure 1. Beside it, we construct a second square of the same size. We attach another square to it, which has the length 2. To this is added a square with the length of the side 3, one with the length of the side 5, one with the length of the side 8. It is not difficult to recognize the numbers of the Fibonacci sequence. Now we draw a quadrant in each square. The result is a spiral called the Fibonacci spiral. It can be clearly seen in the shell of the Nautilus.